So today we're going to begin review of factoring, which was that very large unit that we started with this year back in September. So the first type of factoring that you learned about was GCF factoring, which is known as greatest common factor. So for example, let's just say that you had x to the fourth minus x to the fifth, and you had to factor, right? So certainly they have an x in common, but they have a little bit more than just one x in common. So the trick with greatest common factor when you're comparing two different exponents is you take the lower of the two. So the greatest common factor between these two terms would be x to the fourth. And we want to make sure that we bring down that subtraction symbol. And to figure out what you're going to be getting in the parentheses, you really are going to be doing a division in your mind. But of course you could show it. I'm going to give myself a little more room. So basically what we want to do is we want to take the first term and divide it by the GCF. And we want to take the second term and we want to divide it by the GCF as well. So if you look at this first group, right, x to the fourth divided by x to the fourth is really 1. And x to the fifth divided by x to the fourth, so the rule there is we subtract the exponents, right? So 5 minus 4 is 1, so it's really x to the first or just x. Example 2. Let's say we had rs cubed minus r squared s squared, and your job was to factor, right? So now we have two different variables here. We have r and we have s, so we have to sort of take them into account individually. So first let's take a look at the r's, right? So the trick when deciding greatest common factor is you steal the lower of the two exponents, right? So although we don't see it, we know that this is r to the first. So between 1 and a 2, the 1 is lower. So r to the first, or r, is going to be part of our GCF. And if we look at the s's, we have to compare s cubed and s squared. And when we're talking about GCF, again, you steal the lower of the two exponents. So s squared will be the other part of our GCF. Okay, I'm going to make sure we steal down our subtraction symbol. And to get the parentheses, we have to divide the first and second terms by our GCF. So we have to take this term and divide it by rs squared, and this term, and we have to divide it by rs squared, right? So let's take a look at the first term, and let's just talk about r divided by r. Of course, that's going to reduce out to be 1. And s cubed divided by s squared. So when we're dividing the same base, we subtract the exponents. So 3 minus 2 is 1. So that's really going to be just s to the first, or just s. So there's no r in the first term of our parentheses. And let's take a look at the second term. So r squared divided by r is just going to be r. And s squared divided by s squared just reduces out to be 1. So there's no s in the second term of our parentheses. And let's take a look at question 3. So let's just say that we had x to the sixth minus 9x squared. So back to only looking at one letter. So when we compare x to the sixth and x squared, and we're talking about factoring, we steal the lower of the two exponents. So the GCF is just going to be x squared. And we will take the first term, divide it by the GCF. Take the second term, divide it by the GCF. We'll make sure we steal down our sign. X to the 6th divided by x squared. 6 minus 2 is 4, so that'll be x to the 4th. And x squared divided by x squared is really just 1, and we're still left with that 9. Now this is a little bit of a different scenario because the parentheses can further be factored. And what we're looking at inside the parentheses here, x to the 4th minus 9, is known as difference of two squares. So that's going to lead us to our second technique of factoring. So let's just talk about difference of two squares initially, and then we'll get back to that last problem and finish it out. So the D stands for the word difference. And in math, that means that we're talking about subtraction. That in quotes. Okay. This just stands for the word of. This stands for the word two, meaning two terms or a binomial. And the S stands for square. Difference of two squares. So the problem that we left off with that wasn't quite finished was this one. Okay? So let's talk about why the parentheses right here fits into the category of being difference of two squares dots. So first and foremost, we have subtraction. And we have two terms. So we're looking good to start with. Now, in order for the parentheses to be difference of two squares, each term has to be a perfect square. And we know that 9 is a perfect square. The square root of 9 is 3. And x to the 4th. So when we're talking about difference of two squares, we want the exponent to be an even number. It doesn't have to be a perfect square. The exponent has to be an even number. So difference of two squares breaks up into two individual factors, one being positive and one being negative right here. And essentially what we want to do is we want to square root x to the 4th and we want to square root 9, right? So the square root of x to the 4th, when you're square rooting a base with an exponent, we divide the exponent by 2. So that's going to be x squared, and we know the square root of 9 is 3. So x squared is going to drop in the first terms of each parentheses, and 3 will be second. And then what you're really supposed to do is look at the answer that you have here and say, can I break any of those factors down any further? So in our first parentheses here, it's not a difference of two squares for a couple of reasons. The major reason is that, first of all, there's an addition here. And for difference of two squares, you have to be subtracting two terms. So right off the bat, that first parentheses is not a difference of two squares. In the second parentheses, we have a possibility of being difference of two squares because we do have the subtraction and we do have two terms. X squared is a perfect square, but 3 is not a perfect square. The square root of 3 is an irrational number. So after looking at this answer, we can conclude that it is broken down fully. So I think we're up to question number 4. So when you see the phrase in directions, and it says factor completely, that word completely is telling you that you really want to double check your final answers to see if any of the factors that you have in front of you can further be broken down, right? So always watch out for that word completely. Okay, so let's take a look at this one. Let's do x to the 10th minus 16x. So the first type of factoring, remember, is greatest common factor. So if we look at these two terms, I definitely see that there is a greatest common factor. If we compare x to the 10th and x to the 1st, right, greatest common factor, we want to steal the lower of the two exponents. So the GCF is going to be x. And let's try to figure out what we're going to have in parentheses here. So we're going to divide both of our terms by the GCF of x. So we're going to have x to the 9th, right? 10 minus 1 is 9, x to the 9th. We want to steal down the subtraction symbol. And x to the 1st divided by x to the 1st reduces out to be 1. So we're really just left with 16 here. But now what we want to do is we want to focus our attention on the parentheses, and we want to say, can we further break down x to the 9th minus 16? So what we want to ask ourselves is, the possibility that we have is this difference of two squares? So let's go over our checklist. So for difference of two squares, we need subtraction, and we do have that, so that's good. We need two terms, which we have two terms in the parentheses there, but we need both of those terms to be perfect squares. So let's consider the square root of x to the 9th and the square root of 16. So we know the square root of 16 is 4, so far we're looking good. And then we get to the square root of x to the 9th. So there's always going to be a common mistake out there with students when they see the square root of x to the 9th. See, exponents cannot be treated like regular constants, right? So the common error right here is that students will say the square root of x to the 9th is x to the 3rd. And that is incorrect. But you could see why a classmate of yours might think that, because they're thinking really what the square root of 9 is, right? The square root of 9 is 3, but 9 is an exponent here, it's not a constant. So if you think about the last problem that we just went over, I had mentioned when you're square rooting a base with an exponent, you're dividing the exponent by 2. And what happens here is 9 is not divisible by 2. It actually gives you 4.5. So the square root of x to the 9th, well, it's simply not perfect. So therefore, since 9 is not an even number, x to the 9th minus 16 is not difference of two squares. So we were looking at our final answer. And we will do another one for good measure. So let's consider x to the 8th plus 4x squared. So the GCF I can see here is x squared, right? We want to steal the lower of the two exponents. So x squared is our GCF. And then we want to divide these two terms by our GCF. So x to the 8th divided by x squared, we would really subtract the exponents. So that would be x to the 6th. Hopefully you didn't fall into the trap of saying x to the 4th. Right? When we're dividing these exponents, we're truly subtracting them. Right? we want to steal down our symbol. And then over here, x squared over x squared will reduce out to be 1, and then you have a 4 here. And then once again, what you want to do is you want to ask yourself, in the parentheses, can you further break that down? So since we have two terms here, what we would want to consider is difference of two squares. And I do think that we have two squares here, right? If we consider the square root of x to the 6th and the square root of 4, the square root of x to the 6th, and remember, you're not square rooting the 6th. When you're square rooting x to the 6th, you're really dividing the exponent by 2. So this will be x to the 3rd. And the square root of 4 is 2. So right off the bat, I definitely know that I'm working with two squares. The problem is that we're not working with the difference of two squares, right? Difference implies subtraction. So at first glance, one might think that you can further break this one down, but it is not difference of two squares because of the plus sign. So once again, we do have our final answer.